Alright guys, we're here to take a look at our 2.4 notes today. In 2.4 we're going to go ahead and have variables on each side of the equation. So this is different than anything we did in 2.1, 2.2, and 2.3. But I think most of you are going to pick it up fairly easily. Okay? So some equations like 3x minus 9 equals 6x have variables on each side of the equal sign. We are going to use the addition or subtraction property of equality to write an equivalent equation with variables only on one side of the equal sign, and then we'll solve the equation. So basically all we're doing in comparison to 2.3 to 2.4 is we're either going to add or we're going to subtract one of the two variables to move it to the other side of the equation. And then after we do that, it will be just like an equation we solved in 2.1 or 2.2. So it will turn into a one-step equation or a two-step equation after that point. Okay? I don't like the way that they wrote out the example here. So I'm going to write it out to the side just to show you kind of what it looks like, how you traditionally see me write it out. Okay? So I'm going to take this same example problem and just write it over here to the side. So we have 3x minus 9, which is equal to 6x. Okay? So again, the difference here is we now have a variable on the left, which is the 3x.
Please call extension 1204, Susan Lance. Please call extension 1204. Thank you.
And we have a variable on the right, which is a 6x. Okay? So because of that, this is where things are a little more challenging. And what we need to do is, instead of having a variable on the left and on the right, we want to use addition or subtraction to move the variable so that they're both on one side. Okay? Most of the time, it's to our benefit to move the smaller of the two variables, because if we move the smaller of the two variables, many times that will help us by not having so many negatives to work with. Okay? So in this case, we have a 3x and we have a 6x. So 3x is smaller, so I'm choosing to get rid of that. So in front of the 3x, I don't have a sign. Anytime I have a sign there, I want to pay attention to it. But because we don't have one, I know it's a positive 3x, so we want to subtract 3x so that it becomes 0 and goes away. All right? So on the left side, that subtract 9 comes down, and it actually becomes negative 9 now. And on the right side, 6x minus 3x is 3x. All right? And then at this point, it's just like what we did in 2.1. It's a one-step equation. So I need to get rid of the 3 that's over there with the variable. So we do that by using division. And negative 9 divided by 3 is negative 3. All right? And just like what we did in 2.1, 2.2, and 2.3, we can always take that and we can check it to make sure that it works. The difference in this, as you can see over here, we need to plug that in to the left side of the equation and solve. So we took 3 times negative 3, which gave us negative 9, and if we subtract 9 more, we end up with negative 18. So the way I do these is I work out the left side completely and get the answer, and then I'll take it and plug it into the right side. And so we plug it in here where the x is at. So 6 times negative 3 gives me negative 18. And then we check. Is negative 18 equal to negative 18? Yes, the sentence is true. So because it's true, we know that our answer of negative 3 is correct. Okay? All right, example number 2. So again, I'm not a huge fan of how they have it written out. They write theirs more horizontally, where we write ours more vertically typically. So I'm going to go ahead and bring this over again, just so you can see what it would look like, how we typically write them out here. Okay? So again, paying attention to which of the two variables is smaller. Again, this is an option. You don't have to do this by any means, but typically it will be more beneficial to you. So I have a 4a, and again, I don't have a sign in front of it, so I know it's positive, but over here we do have a sign in front of it. So my little helpful tip for most people is to not think of that as a subtraction sign, but to think of that as a negative 2. So I have a positive 4a or a negative 2a. So we know that the negative is smaller, And so that's what I want to get rid of. So if I'm subtracting 2a or I have a negative 2a, I want to get rid of that and make it become 0 by adding 2a on each side. One other thing that's helpful is notice that I'm lining up my like terms, so anything that has the same variable, I'm lining that up, okay? So over here on the left, 4a plus 2a becomes 6a. The subtract 7 drops down, which is equal to 5. All right? Now, this is just like our equations that we solved in 2.2, where it's a two-step equation. So now that I have the variables together on one side, the left side is more important. So I have the 6a, or the 6 times a, and subtract 7. So we want to go ahead and get rid of the subtract 7 by adding that to move it to the right side of the equation. Because remember, our goal is to get the variables on one side and the number or our constant term on the other side. All right, and so we have that. So now to get rid of the 6, we divide, and 12 divided by 6 is 2. Again, you could plug that back in and check that to make sure that the left side was equal to the right side. Okay. All right, on the back of the paper, we have quite a few more examples. The directions say solve each equation and then check your solution. Just to save some time here, I will not be checking them all. Okay, I'll check the first 3 and then the rest I will just solve them out. Okay. So here we go. Looking at number 1, we have 6 times s subtract 10 equals 1s. We do have that hidden 1 there, so that's helpful for a lot of people to remember that. Again, you know, this is when you have the choice. You could either move the 6s or you could subtract the 1s, okay? Either way, 1 is smaller than 6. However, if you get rid of the 1s, you need to be careful, okay? So if we choose to subtract the 1s, when I get rid of it over there on the right side, because I don't have anything to bring down, I must bring a 0 down to hold my place value on the right side of the equation. Okay, on the left side of the equation, I have 6s minus 1s, which is 5s, and then subtract 10 also comes down. Okay, at this point, again, the left side is more important because that's where the variable's at. So I want to get rid of the subtract 10 by adding 10 on each side. So the 5s equals 10. And then we want to divide each side by 5. And s equals 2. Okay? And again, you could check that by replacing it in the original equation on the left side and on the right side. So again, I choose to solve out the left side first and get an answer, and then solve out the right side second. So 6 times 2 is 12. 12 minus 10 becomes 2. And then on the right side, if I take 1 times 2, we get 2. And those two answers are the same, which tells us that our answer to number 1 is correct. Okay, here's number 2. I have an 8r and a 4r. Okay, 4r is smaller. In front of the 4r, we don't have anything, so we want to subtract. Okay, this is a very common mistake because a lot of people see the subtraction sign here and just choose to go ahead and add. But remember, our goal is to get it to go away on one of the two sides. So if I already have positive 4r, to get 0r, we need to subtract 4r. Okay? 8r minus 4r becomes 4r. And that subtracts 16. Again, a common mistake is people forget to bring that subtraction sign down, which now turns into that negative 16. All right, and now I want to get rid of the 4, which gives us r equals negative 4. Again, we can plug this back into the original equation, and we can check to make sure it works out. So on the left side, I've got 8 times negative 4, which gives me an answer of negative 32. On the right side, I would take 4 times negative 4, which is negative 16, and subtract 16, which also gives me negative 32. So because the left side and the right side of the equation are equal to each other, that tells us that we are correct with number 2. All right, number 3. again, helpful little hint here. That subtraction sign, we can really think of it as a negative 3u in comparison to a positive 2u. So negative 3u is smaller. So because it's negative, we want to go ahead and add 3u to make 0. The 25 drops down, and on the right side, 2u plus 3u becomes 5u. We're going to divide each side by 5, and 5 equals u for the final answer. And again, this will be the last one that I checked for you guys, but if we take 25 minus 3 times 5, which is equal to 2 times 5, again, the left side and right side should equal each other. So I need to bring down the 25. If I take 3 times 5, we get 15. 25 minus 15 becomes 10. On the right side, 2 times 5 is 10. And I bring those down, and I notice that, yes, 10 is equal to 10. So it proves that 1, 2, and 3 are all correct. Okay? So from here on out, all I'm going to do is solve them. So starting with number 4, we're going to go ahead and solve these, but we are not going to check them. Okay? All right, so I have a 14t and a 6t. So again, 6t is smaller. But as I was saying earlier, that is your choice, okay? And I know, because I've solved a ton of these, that it's actually longer process on this particular problem, because if I get rid of the 6t, I don't have anything left over on the right side of the equation. And so I'm going to choose, and also just prove to you, that it doesn't matter which variable you choose to move first. So this time, instead of choosing the smaller one, I'm going to choose to get rid of the larger one, okay? So the negative 8 drops down, and on the right side, 6t minus 14t becomes negative 8t. And I've got one step equation left, so I divide each side by negative 8. Negative 8 divided by negative 8 becomes positive 1. And that is our answer. All right, on number 5, again, we have a hidden 1 in front of the k. And I'm comparing 1k to 9k. 1k is smaller, so that's where I would want to start with subtraction. The 20 drops down. 9 minus 1 is 8k minus 4. I now need to get rid of, on the right side, because that's where our variable is at, so I need to get rid of minus 4 by adding 4 to each side. It gives us 24, which is equal to 8k. I then need to divide each side by 8, and 3 is the final answer. Okay? Number 6, I have an 11m compared to a 1m, so 1m is smaller. So I'm going to subtract 1m on each side. That gives me 10m plus 13 equals 23. The left side has our variable, so I need to get rid of the addition first by using subtraction. 10m is equal to 10, and then I need to divide each side by 10 to get a final answer of 1. All right? Again, I'm trying to go through these as quickly as possible, so please feel free to pause the video if you need to check those out, or to go back and work through these. Okay? Number 7, we've got negative 4b in comparison to positive 3b. So the negative 4 is what needs to move by using addition. Again, that is your choice. If you choose to move the other one, that would be okay. You will just end up with some more negative numbers. But in the end, you will end up with the exact same thing. Okay, so you subtract 9 on each side, get negative 14 equals 7b, divide by 7, and you end up with negative 2 for your final answer. Number 8, again, we have a hidden 1 over there on the right side. So I have 6y or negative 1y. So the negative, or the subtract 1y, is what we're wanting to move. So the 6y and 1y becomes 7y minus 1 equals 27. I want to add 1 on each side. 7y is equal to 28. Divide by 7, and y is 4. And now, with number 9, 10, 11, and 12. Okay, so as you guys should know, In our class here, a lot of times we try to keep things as whole number answers because that kind of helps you decide if you've done it right and, you know, just making them a little bit easier for you. But in the real world, that's definitely not the case. You can have fractions, decimals, all kinds of answers, okay? And so with 9, 10, 11, and 12, you do get some decimals here, all right? So we've got 1.6h or 4h. And with that, 1.6 is smaller, so we want to go ahead and subtract 1.6h from each side. So the negative 72 drops. If you take 4 and subtract 1.6, that gives you 2.4h. And the subtract 30 tails in behind it. Because it's subtract 30, we want to add 30 to each side, which gives us negative 42 equals 2.4h. And to get rid of the 2.4, we divide each side. And we end up with negative 17.5 for the final answer. Again, even though this is a decimal answer, or you could turn that into a fraction, you still plug it back into the equation just the same. Solve out the left side, see what it equals. Solve out the right side, see what that equals. And then if they're both equal to each other, that is your correct answer. All right? Number 10, we have a negative 3z or a negative 8z. Again, negative 8z is smaller, but because I know that negative 8z is by itself, I really don't want to move it. I want to move the negative 3z. So I'm choosing to not follow that kind of rule of thumb of moving the smaller one, since the negative 8z is by itself on the right side of the equation. Okay? So I'm choosing to move the 3z by using addition, which means the 8.5 drops down. If I have negative 8 and add 3, we get negative 5z. I divide each side by negative 5, and I end up with negative 1.7 for our final answer. Number 11, I have 10x or 5x. 5x is smaller, so we want to subtract the 5x because there's nothing in front of the 5x. Remember, the sign behind it, that subtraction sign behind the 5x, is only dealing with the 3. It has nothing to do with the 5. So this is a very common mistake of people seeing that subtraction sign and thinking immediately, well, I need to add. Okay? So always pay attention to what's in front of it or on the left side of whatever you're trying to move. Okay? All right, the 10x minus 5x becomes 5x. The plus 8 drops down, and the subtract 3 becomes negative 3. I subtract 8 on each side, which leaves us 5x is equal to negative 11. Divide each side by 5, and we end up with negative 1.2. All right, number 12. Again, that subtraction sign in front of the 7d kind of turns into a negative 7d in comparison to a negative 3d. All right, so I would like to get rid of the negative 7 by adding 7 on each side so that that becomes 0 on the left. The 16 drops down. If I have negative 3 and add 7, we get 4d plus 2. We then subtract 2 on each side to give us 14 equals 4d. I want to divide by 4 on each side, and we end up with 3.5 for our final answer. And that wraps up our notes on 2.4 with equations on both sides.